Hello and welcome everyone. Today we are looking at factoring polynomial expressions, lesson 3. So in lesson 2 we looked at factoring trinomials in the form x squared plus bx plus c. And we are just going to expand on that a little bit today and look at a couple of special cases where you need to use a little bit of a trick, but it's the same process. So hopefully it doesn't seem too different. So we're just going to do a quick review. So review of factoring by inspection. So if we are looking at this example here, x squared plus 6x plus 9. First of all, we check if we need to factor a common factor out. There's no term in front of the x squared, or no coefficient. So that's good. And now we're just looking for two numbers that multiply to 9 and add to 6. So we need to find two numbers whose product is 9 and whose sum is 6. In order to factor the next one, x squared plus x minus 12, we need to find two numbers that multiply to negative 12 and add to positive 1. Remember, there's a 1 in front of that x there. So two numbers whose product is negative 12. Don't forget the signs. There's a negative in front of that 12. And whose sum is positive 1. This is a really nice tidbit of information. If the product is positive, If the product is positive, then the two integers must be either both positive or both negative. So if the number you're multiplying to is a positive, then your numbers are either going to be both negative or both positive. If the number you're multiplying to is negative, then one integer is going to be positive and one's going to be negative. All right, so we're going to get into a couple more examples here. The first three are similar to the ones that we did last lesson, so maybe I'll just do one of those, and then when we get down to class example 2, there are a couple more where you have to use a bit of a trick. So let's do B. So I see here I have a trinomial in the form x squared plus bx plus c. I don't have a constant or a coefficient in front of that x squared, and I don't need to factor out any common factor. So now I can just set up my brackets, x, and I'm looking for two numbers that multiply to negative 18 and two numbers that add to positive 3. So I like to use a multiplication chart, looking for negative 18. So I've got 1, negative 18, negative 1, 18, 2, negative 9, negative 2, and 9. What else do we have? 3, negative 6, negative 3, and 6. So I need to find two numbers in that set that add to positive 3. And if you look through, you can see negative 3 plus positive 6 would equal positive 3. So now my answer is going to be negative 3 plus 6. So that's your answer right there. X minus 3 multiplied by x plus 6, two binomials. And we have factored that trinomial. So factoring a trinomial is just opposite of foiling, which is kind of cool. If you wanted to check your answer, you could do a quick FOIL as well. FOIL to check. And then you would do first, outside, inside, last, combine your like terms, and you should get the trinomial that you started with. Awesome. Hopefully that is all. You all remember that, or you all know it. It's not new information for you. Let's look at b first in the next example. So looks like I have a trinomial. It's 3 terms, which is awesome. But the issue is I have a 2 in front of my t squared term. We don't want to have any coefficient on that term. So what you can try to do is factor it out, but you need to factor it out of every term in that trinomial. So what we could do is, let's factor out 2. And what are we left with? Well, if we pull a 2, if I divide that by 2, they cancel, and I'm left with t squared. If I divide 2 out of the next one, negative 14 divided by 2, negative 7t. And positive 20 divided by 2 is plus 10. Now that I factored that 2 out, I am going to factor that trinomial. It's important that that 2 stays there. It's part of the expression. And now I'm just going to find what numbers go in my factors here. So I'm looking for 2 numbers that multiply to positive 10 and add to negative 7. So I can see that the sum term right here, the one I'm trying to make add, is a negative term, right? So it's negative 7. So I keep that in mind when I'm doing my multiplication table, because 1 times 10 is positive 10, but negative 1 multiplied by negative 10 is positive 10 as well. 2 times 5 and negative 2 times negative 5. That's important because, as you can see, the 2 numbers that are going to work are both negative. Negative 5 multiplied by negative 2 is positive 10, but negative 2 plus negative 5 is negative 7. So then it's minus 2 minus 5. So the whole answer is 2 multiplied by t minus 2 multiplied by t minus 5. So for the next one here, let's do c. I can see that I don't need to do any factoring. There's nothing out front that would require me to do pull out a common factor anyways. So now I'm going to try to factor it into 2 terms there. So I'm looking for 2 numbers that multiply to negative 6 and add to negative 3. Okay, well, numbers that multiply to negative 6. 1, negative 6, negative 1, 6, 2, negative 3, negative 2, and 3. Do any of those add to negative 3? Well, 1 plus negative 6 is negative 5. Negative 1 plus 6 is positive 5. 2 plus negative 3, negative 1. Negative 2 plus 3 is positive 1. None of them seem to work. When that's the case, double check to make sure you have all the factor pairs of negative 6, and I think that we do. So if that's the case, this one just is not possible, and that's going to happen. Let's do D now. I'm going to go with D. We'll come back to A. I'm going to do A as well. I just want to do it last. Okay, so in D we have 4x to the power of 4 minus 16x cubed minus 20x squared. And we know when we are solving these trinomials, we want to have it in the form x squared plus bx plus c. So 2 things. We want to have no coefficient on the x squared term, and the highest degree we want is x squared. So we need to fix both of those problems in this trinomial if we can. If we can't, no big deal. So first thing I want to do is factor out a 4, but I also need that to become x squared. So if I factor out 2 x's, which I can do from every term has an x squared to give, we'll see what happens. So if I factor out 4x squared out of the first term, 4 divided by 4 is 1, so we're not going to write that down. X to the power of 4 divided by x to the power of 2 is x to the power of 2. Next term, negative 16 divided by 4 is negative 4. X cubed divided by x squared is just x, taking 2 out of that. Next term, negative 20 divided by positive 4 is negative 5. X squared divided by x squared would just cancel out. So I've pulled the greatest common factor out of each of those terms. And I'm left with a trinomial that is x squared minus 4x minus 5. It's in this form that we want. So now we can factor it properly. So I'm looking for two numbers that multiply to -5 and add to -4. So let's make our little list here. -5, so it's going to be 1 multiplied by -5 or -1 multiplied by 5. Do either of those add to -4? Well, 1 plus -5 adds to -4. So I can put those numbers in, x plus 1, x minus 5. That doesn't look like a very good 5, 5, haha. And there we go. That's our answer. 4x squared multiplied by x plus 1 multiplied by x minus 5. And if you're really unsure and you feel weird about that, combine all of those, right? Multiply all the way through or expand them. And once you do FOIL on these two factors and then multiply that 4x through all the terms, you should end up with the original trinomial. Yay! Okay, I'm going to do A now. The reason I left it till last is it's got a bit of a trick here. I'm going to erase that just so we have some space. We have -a squared minus 6a minus 27. So some of you might notice that there's an issue here. We have a negative sign in front of that a squared. And you can see if we look at the bottom here, the form that we want that trinomial to be in is a positive x squared term. We don't want a negative x squared, but we can pull something out of this trinomial, right? Because this pretty much is like -1a squared. That term is equivalent to -1a squared. There is a coefficient of -1 there. So what you can do is factor a -1 out of that trinomial. And when you factor a -1 out, what ends up happening is you end up changing the sign so that -a squared becomes positive a squared. This -6a becomes positive 6a. So you end up changing the sign of everything in the brackets. Positive 27 becomes -27. That's totally okay. Oh, there we go. So now we can factor this. We have the trinomial in the form that we want it. So I can set this up. And I'm looking for two numbers that multiply to -27 and add to positive 6. So let's set that up. -27. Well, it's going to be 1, -27, -1, 27. 2 doesn't go into there, but 3, -9 works, and -3, 9. Do either of those add to positive 6? Yeah, right here. -3 plus 9 gives us positive 6. So that's our answer. A minus 3, A plus 9. So the trick there is we had to factor out that -1 first, but it stays with us. Fantastic. Almost done. We're going to look at factoring trinomials in the form. So normally we're used to x squared plus bx plus c. But what's happening now is we're bringing in another variable. So it's going to be x squared plus bx plus c, but we're going to bring in another variable, so it's going to look something like this. So x squared plus bxy plus cy squared. There's a bit of symmetry that you can kind of see here. The first term has an x squared, and the last term has a y squared, and then the middle term has just one x and one y. That's kind of the symmetry that we're looking for. And I'll show you how we're going to do that. I'm going to skip this whole part here. I don't really like those fill in the blanks very much. I like doing the examples and showing you. So normally when we were factoring, hang on, let me scroll up. And okay, it won't let me scroll. That's really nice of them. Touchscreen is just not working. Thinks my finger is the pen. Okay, normally when we were factoring an x squared plus bx plus c term, we would write these brackets down and we put an x at the start. And then we were looking for numbers. But now, when we have an x squared and a y squared, what you can do is, wait, I'll just show you an example. So let's go down to example A here. You can see that we have an x squared and an x and a y squared. So now we're going to factor it with the same process. I'm going to break that into two factors, except our first term is going to have an x. And let me try something here. I need to make this a little bit bigger. I learned this new trick where I can grab everything. Haha. Look at that. Okay, the first term is going to have an x. And our last term is going to have a y in each bracket. And what we're doing now is we're still looking for numbers. The two number, and how we're going to find those two numbers is we're looking for two numbers that multiply to 30 and add to 13. Same process that we've been doing. So let's do our multiplication here. So two numbers that multiply to 30. 1 and 30, 2 and 15, 3 and 10. So we're looking for two numbers that add to 13 out of those. 5 and 6 if you wanted to be thorough. And you can see that 3 and 10 add to, positive 3 and positive 10 add to 13. So now I can say x plus 3y. So that 3 becomes part of the y term, multiplied by x plus 10y. And that's how you would solve those problems where you have an x squared, still no coefficient on it. The middle term has to have an x. The last term has a y squared, and the middle term has a y on it. And it's okay if the y squared term has a constant or a coefficient. It most of the time it will, but you still cannot have a coefficient on that x squared term. I'm just going to FOIL these factors out quickly here and show you that it works. So we're going to go x times x. That gives us x squared. That's first. And then outside is going to be x multiplied by 10y, which is plus 10xy. And then we're going to do the inside. 3y multiplied by x is plus 3yx. And 3y multiplied by 10y is 30y squared. And then we can simplify by combining our like terms. And the answer is x squared plus 13xy plus 30y squared, which is what we started with. So we did it right. Yay. Okay, let's look at question C. And then I'll let you guys get to some practice problems. So in C, you can see here that we have an a squared and a, which is awesome, and a b squared and a b. So it is in the form that we were just looking at. The problem is there's a 3 there, and we can't have a coefficient on that first term. So what can we do? Well, we can try to factor a 3 out and see what happens. If hopefully it factors out of every term. So say let's put a 3, and if we factor 3 out of the first term, 3 divided by 3 is 1, so we'll just write it as a squared. That was kind of the purpose of this. Negative 15 divided by 3 is negative 5 AB. And negative 252 divided by 3, pull out your calculator, punch it in, negative 84B squared. So we've successfully factored out 3, and we've turned this polynomial or this trinomial into a form where we can factor it. So it's going to be 3, and then we're going to have two terms, A multiplied by A and B multiplied by B, but we've got to figure out the numbers. So we're looking for two numbers that multiply to negative 84 and add to negative 5. So go through it. Let's do our negative 84 is going to be 1 times negative 84, negative 1 times 84, and then we're going to have 2 multiplied by 42, negative 42, negative 2 multiplied by 42. Let me pull up my calculator here. Let's see if we have 3 and negative 28, negative 3 and 28. 84 divided by 4 is, well, we have 4, negative 21, and negative 4 and 21. Just going to scroll. What about 84 divided by 6? We have 6 and negative 14. And we have negative 6 and 14. Do any of these add to negative 5? We don't think so. So what about 7? 84 divided by 7. So we can have 7 and negative 12, or negative 7 and positive 12. And we're looking for two numbers that add to negative 5. So you can see here positive 7 and negative 12 add to negative 5. I know that was a really long multiplication chart there, or factor pair chart, but it's going to be worth it when you get the right answer. So yeah. So positive 7 and negative 12. Again, you can write them in any order that you want. And it's right. A minus 12b multiplied by A plus 7b. And we have to, don't forget that 3 out there. That's a pretty common mistake. And I will see some of you doing that just because, it is one of those things that gets forgotten about. So make sure that's not you. All right. I think that's it. Hopefully this made sense, and I'll see you guys in the next video.